We will continue our discussion about rates and unit rates, and we will use that information that we learned yesterday to compare rates with one another. If you turn to the next page in your notes, you should see this example. Carrie makes costumes for the musical. She bought 15 yards of material from Michaels and spent a total of $44.25. She bought 35 yards of fabric material from Joann Fabrics and spent a total of $73.50. From which store did she get a better deal? If you notice in this example, it does not ask you specifically which unit rate you need to calculate, as it did in the examples we discussed yesterday. So with a problem like this, you can actually solve it one of two ways. I'm going to have us do both so that we can compare the two different options and make sure that we understand both. The first thing I want you to do is find the price per yard for both Michaels and Joann Fabrics. So taking the price for each and dividing it by the number of yards for each. So price divided by yards. Calculate that first. For Michaels, this is $2.95 per yard by dividing $44.25 by 15. For Joann Fabrics, if you divide $73.50 by 35, you will get a price per yard of $2.10. If we look at these two values to compare which is the better deal, it is obvious that Joann Fabrics is cheaper per yard of fabric. So therefore, Joann's is the better deal. Another way to do this is by calculating a different unit rate, and that is by finding the number of yards that you get per dollar. So now I want you to calculate the number of yards per dollar by dividing those same values that we used in the original problem, but we're going to divide them in the opposite direction. So we're going to divide the number of yards, 15, by the dollars, $44.25. And for Michaels, that is about 0.34 yards per dollar. That means that for every dollar, you get about 0.34 yards of fabric. And then for Joann Fabrics, 35 yards divided by 73.50 is about 48 yards per dollar. In this case, if we are looking at how many yards you get for your dollar, the better deal is still Joann Fabrics because you're getting more yards per dollar. So both times, Joann Fabrics is our better deal. What we have to be careful of is making sure that we're aware which unit rate did I calculate and whether I'm looking for the larger number or the smaller number. So in this case, with dollars per yard, we were looking for the smaller of the two because that is money, so we wanted the cheaper one. And for the second problem, where we were doing the yards per dollar, we were looking for the bigger of the two because the better deal is which one gives you more for your money. Let's try another example. Sam was baking both chocolate chip and snickerdoodle cookies. He was able to bake 360 chocolate chip cookies in 120 minutes and 100 snickerdoodles in 40 minutes. Which cookies bake more slowly? The first thing I want you to calculate is the number of minutes per cookie for both the chocolate chips and the snickerdoodles. So for chocolate chips, that's 120 minutes divided by 300 cookies, which is about 0.33 minutes per cookie. For snickerdoodles, you're doing 40 minutes divided by 100 cookies, which is about 0.4 minutes per cookie. Which one is slower? In this case, it's the one that takes longer. That's the bigger number because snickerdoodles take more minutes per cookie. So here we're looking for the bigger number because it's more minutes, which is slower. And that's snickerdoodles. The other way to do it is find the number of cookies per minute. So now we're going to take those same values and divide them in the opposite direction. So 360 cookies in 120 minutes, that's 3 cookies per minute for the chocolate chips. and 100 divided by 40, which is about 2.5 cookies per minute for the snickerdoodles, which is going to give you the slower bake. Again, we have snickerdoodles because you're getting fewer cookies per minute, so we are looking in this case for the smaller of the two, and that is snickerdoodles. Again, you could solve this problem either way. You just have to make sure that you are paying careful attention to which way you divided your units so that you can make sure you're interpreting your answers correctly. Take a few minutes to try these next couple examples. Pause if you need more time. For this one, the best deal is option C, $1.60 for 64 ounces. If you calculated the dollars per ounce, you would be looking for the smallest amount per ounce. If you calculated ounces per dollar, you would be looking for the biggest amount of ounces per dollar. Another option is to turn all of them into the total larger version, or the container C, which is out of 64 ounces. So I could do that by multiplying 16 by 4 to get 64 ounces and 32 by 2 to also get 64 ounces. If I do that over here on the other side as well, if I double the amount of money and quadruple the amount of money, I can see how much does it cost me for 64 ounces if I'm buying container A or B. So for container A, 72 cents times 4, that's $2.88 for the 64 ounces. And for option B, that's $2.40 for 64 ounces. So obviously here, $1.60 is less than both of those. That's another option, and that works out if, in this case, they're all nice multiples of 64, so you can find that common number of ounces pretty easily. Not always the case, but in this problem, it does work nicely. Okay, this is supposed to represent 2 boxes of chocolates, and the ones with this black-looking almond shape is a piece of chocolate with an almond in it. So which box is nuttier, meaning which box has a larger portion of chocolates with nuts? That is box A. Which of these is the better buy? 12 cans for $4.99 or 16 cans for $6.99? That would be, again, option A.